Hello everyone, let's look at palindrome number. The problem statement is, we want to determine whether an integer is a palindrome. An integer is a palindrome when it reads the same backwards as forward. A couple of examples. Input is 1 to 1. This input integer is a palindrome. But negative 1 to 1 is not. From left to right, it reads negative 1 to 1. From right to left, it becomes 1 to 1 negative. Therefore, it is not a palindrome. Same thing for 10. Reads 0, 1 from right to left, so it's not a palindrome. To solve this problem, I think the most straightforward solution is to convert the input into string, and then reverse the string. Then we compare it with the original input. Let's look at the implementation. First, we convert the input into a string, and then we split it and then make it an array. Then we reverse the array, and then we join them, make it back to a string again. Then we can do the comparison. And finally, we return if the values are the same. Let's submit. It passed. Let's look at the complexity. I think for space, it's constant. But for time, it's O of log 10 of x. So the time consumption depends on how many digits does this input have. If we look at the description here, it has a new challenge. Can we solve this without converting the integer into a string? To solve this problem without converting into a string and do the reverse, I think we can use convert the half of the number. To convert half of the number is because if a number is a palindrome, then the first half and the second half is the same. For example, if the input is 1221, we only need to convert the last 2 digits, and convert value is 12. Then we can do the comparison with the first half. That's also 12. If the input is 12321, we can reverse the simple majority, so we return the last 3 digits, and then we get revert value is 123. However, this 3 is the center digit, and we can just discard this digit because without this digit or not, it won't change the fact that the input number is a palindrome. So when we do the comparison, we can use 123 divided by 10. For the implementation, let's look at the code. First, we can eliminate a few simple cases. For example, if the input number is a negative number, then we just return false. If the input number is greater than 0, however, the last digit is 0, then we can also simply return false. Moving on, let's create a new variable to store the reverted value. And then we can use a while loop to loop through the input number. To stop the loop, we can simply check if the reverted value is larger than the current value. And inside the loop, we need to update the reverted value and the x value. When the loop is terminated, then we can do the comparison and return the result. For the comparison, we compare x with reverted value. Also, another condition is we need to discard the center digit and then do the comparison. So by doing this, we divide 10 and then do master floor. Then we can discard the center digit and then do the comparison. Let's submit. It passed. Let's look at the complexity again. I guess for the space, it's still the constant O of 1. And for the time, when we do the loop, although we loop half of the input integer, but still, the time consumption is proportional to the log 10 of x. So the time complexity is still O of log 10 of x. Thank you for watching. If you have any question, please leave a comment